Welcome back to the final episode of the Hydro podcast, from innovation to implementation. We've spent the last few episodes talking about the digital nervous system of hydropower, from high fidelity digital twins to AI driven maintenance.
It's been quite a journey. But as any engineer or researcher would tell you, the road from innovation to implementation isn't always a smooth, straight line. Today, we're looking at the lessons learned during the hydro.
Exactly. We're moving beyond the theory and looking at what happens when these digital technology tools meet 40-year-old concrete and spinning steel. We've gathered insights from our partners across the Hydro team to give you a roadmap for the future of digital hydropower. For this final episode, just like the first one, we have Deborah from Deep Blue as guest speaker.
It's good to be back and have the chance to conclude this amazing journey with you. One of the biggest takeaways from the hydro is that you can't have a smart plan without good data. But getting that data from legacy, non-digitalized plants is easier said than done.
Right. Xeligence noted that finding the information necessary to build a digital twin is a major hurdle because many plants are decades old. Often, the critical data you need is tucked away in non-digital formats or simply unavailable.
And even when it is digital, it's often trapped in proprietary silos. Our partner at IMT pointed out that mapping this heterogeneous legacy data to modern standards required specialized IoT agents to act as translators.
So, the first lesson for anyone looking to digitize: invest early in sensorization and data access. As Atlantis put it, model quality and accuracy only improve with larger, high quality datasets.
We also saw some fascinating boots on the ground, or rather, drones in the water testing. CERT used remotely operated vehicles, or ROVs, to inspect submerged areas like water intakes.
Indeed, it's a huge safety win because removes the need for human divers in hazardous, cold, or low visibility conditions. But it's not without its own quirks. They learned that the environment around intakes is challenging. The ROV's tether can get tangled on rocks or debris, and even local fauna can interfere with the propellers.
Then there's the hardware itself. For environmental monitoring, Innosense and Iman developed portable biosensors and holographic microscopes. The key lesson there was that real-world reservoirs conditions, like fluctuating flows and turbidity, can impact sensor stability.
Their recommendation: use modular calibration and anti-fouling strategies. If you want sensors to last in a hydropower environment, they need to be easy to maintain on site.
Perhaps the most human lesson came from our software and decision support partners. Mass and AP2K worked on the platform that operators actually use and see.
They found that the most complex algorithm in the world is useless if an operator cannot understand it during a crisis. Mass emphasized the need to balance algorithmic complexity with user friendliness.
And Waterjet echoed this. They found that using graphical visualizations and map-based interfaces makes complex hydrological forecasting much more accessible to non-experts.
AP2K took it a step further with augmented reality, allowing operators to see live hardware status and parameter changes without having to walk across the entire plant. Their lesson: keep it minimalist and simple. When things go wrong, operators need to see exactly what's important without being overwhelmed by buttons or data.
Finally, we have to talk about security. As we connect these plants to the cloud, the digital nervous system becomes a target.
IMT has been working on a zero trust architecture. One fascinating lesson they shared was about dynamic trust scores. Instead of just having a password, the system evaluates the risk level of users and devices in real time based on their behavior.
But operators are often worried about false positives, fear that a security system might accidentally shut down a critical process because it misunderstood an operational change.
That's why the recommendation is to observe trust score fluctuation first and refine policies before enabling any active blocking. Transparency is key to building trust between the human and the machine.
So, what's the final takeaway from the Hydro?
One key takeaway from the Hydro surely is that modernization is a marathon, not a sprint. Xeligence recommends a staged approach, developing, testing, and validating one subsystem at a time rather than trying to do everything at once.
Hydropower might be a centuries old technology, but through the Hydro, we've shown it's ready for a digital rebirth. A huge thank you to all of our partners for their hard work and for sharing these invaluable lessons.
And thank you, our listeners, for following this series. To learn more about the project, the partners, and the tools we discuss, visit thehydroproject.eu.
And remember, stay curious, stay powered up, and keep the current flowing.